Okay, 30, we're going to graph f prime. The slope here is down 2 over 1. We did one like this already, didn't we? So the slope is negative 2 over 1, or negative 2. And the slope is negative 2 everywhere, so the derivative is going to be this guy right here. F prime, oops, let me write it like this. Y equals f prime of x. Alright, part of me wants to go fast so you don't have to take too long on these, but I know if I'm going too fast then it doesn't help you, so make sure you let me know if you use these, because these are for you. 31. Let's see, it's 0 at that point. And again, we talked about this. It's negative, negative, and it's getting smaller and smaller to 0. And then it turns positive and gets steeper and steeper. So I just know it's going to do something like that. And if it's a straight line, if I know this is x squared, if this is a portion of something else, it might not be a straight line. So at this point, we're just going to go with the straight line look, and that's the best we can do with this kind of estimate. Oops, still need that. All right, 40. Okay, these are great questions. A vehicle moving on a straight road has a distance f of t from its starting point. Okay, so here's suppose this is a starting point, and you've got this vehicle, and it's just going to go driving down the road. There's forward, there's backwards, right? Which of the graphs could f prime be for the following scenarios? Well, what does f prime represent? F prime of t is the rate of change of the car or vehicle, which is the velocity of the vehicle. Okay, so we're graphing the velocity when we graph the derivative. Okay, so these are all f prime. So what's happening to the speed here? It stopped, and then it picks up, and then it stays constant. So that would be a car, that'd be B, car with no traffic, all green lights. This one here, you speed up, you go fast, you slow down, you stop. Speed up, go fast for a little while, slow down, stop. Speed up. Okay, so when are you doing that? That's probably a car in heavy traffic conditions. I grew up down in Los Angeles area or Southern California, and that is definitely stop and go traffic. Last one, here's your speed is increasing, decreasing, increasing, decreasing, increasing, decreasing, and there you go. Look at this, a bus on a popular route with no traffic. Okay, I'm going to change out what I did, because here's more of my experience failed me on this graph. This one they're referring to is a car in heavy traffic, because you're going fast, slow, faster, slower down, fast, slow, but you're moving all the time. See, that's just okay traffic, not heavy traffic. But they're referring this to C, because they're calling this a bus that's speeding up, going fast, slowing down, stopping for a little while. There's a bus stop, speeding up, and so forth. All right, so that would be A. Does that make sense? It's interesting thing. I guess it depends on where you're from as to what you think. Okay, 41. Child inflates a balloon, admires it for a while, and then lets the air out at a constant rate. V of t is a volume. V prime of t is the change in volume, right? Or the rate of change, I should say the rate of change in the volume of the balloon. Okay, so at what time does the child begin to inflate the balloon? So this is the rate at which the balloon is getting bigger or smaller, right? So it's getting bigger if this is positive, it's getting smaller if it's negative. Okay, so at what time does he begin to inflate? To finish inflating the balloon, let air out. What would V of t look like if the child had alternated between pinching and releasing the open end instead of letting the air out at a constant rate? Okay, so when did he start to inflate the balloon? Well, this is the rate of change in the volume. So once you start blowing the balloon up, this is going to be positive, right? Because you're putting air in the balloon. So he's going to start it at 3. And when does he stop inflating the balloon? Well, you're blowing air in, even at this point here, you're blowing the balloon up. The volume is changing. Say it's cubic inches at 1 cubic inch per second, if this is seconds. So it's still this is still positive. V prime is positive all the way up to 9. So at 9, you're no longer increasing the volume in the balloon. So from 3 to 9, V prime of T is positive, which means the rate of change of air in the balloon of the volume is positive. That means it's growing. Now at 9, no more air goes in the balloon. Volume stays the same. There's no change in volume. Right? So finish inflating the balloon at 9. Begins to let air out at, looks like 13, because now the volume V prime of T is negative, so the volume's going down. It's going down, 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 and then what happens right here? Okay. Oh, the change of the volume is 0, so the volume isn't changing, so the balloon is, there's no more air in the balloon. Okay, what would it look like if a child had alternated between pinching and releasing the open end of the balloon instead of letting air out at a constant rate? It would have done something like this. There's no change in the balloon here. You let air out, and then you stop. Let air out, stop. Let air out, stop. Okay, does that make sense? So there's no change at those points when you're pinched. And I guess it could probably do this. Pinch, hold it, let it out, pinch, hold it, let it out, pinch. It's kind of like that sort of thing. Okay, we're going to hit on this a lot more in class this week as well. Like, what exactly does this mean? And so forth. Okay, does that make sense? All right. If not, ask him. We'll talk about it in class.